Okay, let's go ahead and get started here on these lesson 9 practice problems. Number 1, a circle with, fix my pen, a circle with a 12-inch diameter is folded in half and then folded in half again. What is the area of the resulting shape? So I just copied and pasted a picture I found on Google here, and folding that circle in half does not change the diameter. It's still 12 inches that way, right? That's still going to be 12 inches. All right, and I'm going to get rid of that because I'm going to move this. And then I'm going to move this over. And then folding it in half again does change the diameter. Okay, so now that 12 is half of what it once was, and so that's 6, right? I'm talking about that part right there. Now it's a radius. That's what we're looking at there. It's a radius. So this basically is asking what's the area of the resulting shape. So we're looking for the area of the fourth of a circle. We're looking for that fourth of a circle. All right. So yeah, I would just basically, what I would do for this one is just do area of a circle, pi times radius squared, and then multiply by 1/4, or divide by 4. Either way is fine, and then that'll work. So I'm going to do 1/4 times 3.14 times, now the radius is 6 squared. So that's going to be 1/4 times, I'm going to put 36 there, because you could change the order of multiplication, right? You could change it. So 6 squared is 36 times 3.14. And the reason I want those together is because 36 divided by 4 is 9, right? So now you got 9 times 3.14, which is going to be the area. 28.26. I should have that memorized. All right, so you got that one. All right, for number 2. This is an interesting one. Find the area of the shaded region. Express your answer in terms of pi. All right, that makes it seem like it's hard, but actually keeping it in terms of pi makes it really easy. Makes it a lot easier, at least. Makes it a little bit more algebraic, but doesn't make it too bad. All right, so find the area of the shaded region. All right, so what we're going to ultimately have to do here is we're going to have to find the area of the rectangle. Okay, we need to find the area of the rectangle. Okay, find the area of all that, and then start taking away the circles, right? Taking away the circles, and taking away, that means subtract, right? We're going to subtract those circles. So we're going to subtract. All right, so let's just get that out of the way. So the area of the rectangle is, we need to know what this is. Well, that's going to be this, right? So 3 plus 6 plus 9 plus 12 is 30. So that's 30 inches. So the area of that is going to be 30 times 18. So 30 times 18, which is 540. And that's inches, right? So that's going to be 540 square inches. Okay, now hold on to that. All right, that's going to be a number we're going to subtract from. Okay, that is what we're going to subtract from. Now the circles right here, if you look closely, these circles, the giveaway here is that these little markation, like these demarcation lines right here, that's 12, right? That right there, that's 9. And right there, that is 6. So what that is essentially doing is showing you the diameter, right? That's showing you the diameter of each circle. So that's going to tell you the diameter, which then in turn will tell you what the radius is. So it's 12, right? It's 12 from there to there. So that means the radius of this circle is 6. Okay? That's 6. I'm going to keep doing this. All right. So this one has a diameter of 9. So the radius is going to be 4.5. Right there. 4.5. Now this one's got a diameter of 6. And so that means it has a radius of 3. Let's keep the consistency with my colors here. That's 6, all right? And I used black for this. And I'm using the wrong number, by the way. That's a 3. And I used a black for this. That was 6. Okay, I got off my color scheme there, but whatever. We've got, now we've got enough information to figure out the area of those squares. So, of those circles, I mean. So you got the circle, we'll call this circle A, this is circle B, circle C. So area of A is going to be pi times radius squared. So you're going to do pi times 6 squared. Now remember, it tells you to keep it. It reminds you to keep it in terms of pi. So we're not going to do anything with that pi. We're just going to keep that kind of stuck to the number. The number is going to be like a coefficient, you know, and pi is going to be the number we're multiplying by. But 6 squared is 36, so that's 36. That is 36 pi. Okay, it's inches squared, but I'm just worried about the numbers right now. So we got circle A is 36 pi. Now area of B, we're just going to kind of do this similar way. That's going to be pi times 4.5 squared. All right, and 4.5 times 4.5 is 20.25. All right, pi. All right, and then circle A, or C, pardon me. Circle C. C is in dog, right? C is in dog. D is in cat. That's bad. That's bad. But whatever. We got, so pi times 3 squared, which equals 9 pi. All right. So we've got all our areas, at least in terms of pi, except for the rectangle. We didn't need to use pi because that's not circular in any way. It's got circles taken out of it, though. And next what we want to do is kind of join all this up. We're going to add all this up together. So add that up. So 36 plus 9 pi, that's 45 pi. Plus this is going to be 65. So I'm going to write another note here because it doesn't hurt. So the total circle area is going to be 65.25 pi, or 65 1/4 pi. There it is. And then the area, it's not going to be a very satisfying answer, I know, but the area is going to be just an expression. It's going to be area of the rectangle, 540, minus 65.25 pi. And that's, I know that doesn't look very good. It looks like another math problem, which it is, you know, but it's also an expression, which we can work that out because we know what pi equals. Pi is a mathematical constant, but 640 minus 65.25 pi. Good enough, right? Number 3, the face of a clock has a circumference of 36 inches. What is the area of the face of the clock? All right, this is good. We haven't done one like this yet. So we've got circumference, and we need to figure out area from that. That's interesting. So we know the distance around it. The distance around it, circumference-wise, is 63 inches. So 63 inches. So let's figure out how we arrived at that 63 inches. Well, circumference equals pi times diameter. Pi times diameter. So in order to do that, we probably did 3.14 times diameter. We're not sure what the diameter is, because we're going to figure that out. But we do know that that's 63, right? We do know that that's 63. So we're going to do, for that one, we're going to divide by pi. So divide both sides by 3.14. So we're going to do 63 divided by 3.14, and I get, for the diameter, I get 20.063 something. I'll just leave it 0.06 inches. All right, and then the radius is going to be half that. So half that should be 10.03 inches. Okay, and the radius was good to get, The radius was good to get because now that in turn will tell us how to find the area, right? Because area, notice how every time I do an area or circumference problem, I always write down the formula. It does not hurt to do that. But pi times radius squared. Pi times radius squared. So we're going to do 3.14, right, times 10.03 squared. 10.03 squared. Right? So let's do that. And I got 315.886, so I'm going to make that 89 to round it, square inches. So there's your area of the clock. So 315, almost 316 square inches. Not exact, but good enough. All right, number 4, which of these pairs of quantities are proportional to each other? For the quantities that are proportional, what is the constant of proportionality? So here, let's just do this right away. Anything area is not going to be proportional. So, because that's, that involves doing radius times radius. So that's going to make it not proportional. And so anything radius, I'm going to mark those off, that one and E, right? So the rest should be proportional, right? The rest should be proportional. So what is the constant of proportionality? So the radius to diameter. So the radius to the diameter. Well, whatever the radius is, whatever the value is of the radius, we multiply by 2, right? We multiply by 2. So there's the constant proportionality right there. So we can say constant proportionality for A is 2, because radius times 2 is diameter. So if the radius is 5, the diameter is 5 times 2. If the radius is 7, the diameter is 7 times 2, 14. Okay? And then radius and circumference of a circle. All right, and so for this one, now radius to circumference. Now radius is not really part of, well, I mean, it's 2 pi r, so we can do that. So you're going to do, let me just kind of do the same thing I did. So for radius, to circumference. All right, we've got r, and then we're going to multiply that by 2 pi. 2 pi. So there's your constant of proportionality for that one. So every time you multiply by 2 pi, you're going to get the circumference of whatever that circle is. So 2 pi r. So the constant proportionality is 2 pi. All right. D, diameter and circumference. Diameter and circumference. So to get from diameter to circumference, all you have to do is take the diameter and multiply by pi, right? That's all you gotta do. Multiply by 3.14. So that is your K for constant, right? Constant proportionality is pi. Okay? Or 3.14, whatever you choose. Or 22/7. Number 5, find the area of this shape in 2 different ways. We got 2 different ways. All right, so let's do the first way. Let's break it up. All right, let's do that. Let's break it up. So what I see here is I'm going to try to avoid having a trapezoid, even though we could break it up. One of the shapes could be trapezoidal. But I'm going to do this. We've got a triangle. Okay, got a triangle. Rectangle here. I'm doing a really terrible job of tracing, by the way. But you got triangle. This rectangle. This is a small rectangle that's right there on top. And then you've got this larger one. That probably has the largest area of all the 3 shapes that we're breaking it up into. And let's do this. So we've got, now right here, that's 1, right? Right here, from here to here, is 3, right? It says so. So that means this must be 2. But 2 meters right there. That's 2. Okay? And then this right here, the height of that triangle is going to be 2. Because this has got to be 2. Because the whole thing, it says over here, that's 4. So you have to kind of scan the shape a little bit. You got to look around, look across from things, look, on the opposite side. Look at all those things, and that will kind of tell you what we're dealing with. So the area of a triangle, I'm going to write down the formula for it. Area of a triangle is base, the one that you guys always prefer using, base times height divided by 2. Base times height divided by 2. So we're going to do, for that one, we're going to do 2 times 2. Lots of 2's here, divided by 2. 2 times 2 is 4, and 4 divided by 2, I guess what that is, that's going to be 2. All right. So that's got an area of 2 square meters right there. Okay. It's right there. That's 2. All right. The rectangle right next to it, that's easy. That's 2 times 1, right? So let's just do that. That's going to be 2 square meters. All right, so that one is finished. All right, and then last but not least, this large one right here. This one I've already written in plenty of numbers, so we should be able to figure out what it is. It's going to be 3 times 2, which is 6. That is going to be 6 square meters. Add it all up, and you get 10. 6 plus 2 plus 2. All right, so there's your area. So the area equals 10 square meters. Right there. Now let's do this another way. Let's do it another way, and hopefully get the same answer, right? If we get a different answer, then did this all for nothing. But I'm pretty sure we did this right. Okay, Now, another way to see it, this kind of also, depends on how your brain works. A lot of us kind of see things differently. But what I see here is, and this is what I probably would have initially done when I saw this shape. What I see here is I see one large rectangle, 3 by 12. I mean, it's not that huge, but it's larger than the rest of the stuff. I see that, and then I see this negative space here. This negative space, that's like somebody cut away a triangle, right? Someone cut that away. But yeah, someone cut this away. It's no longer there. So that's being removed. Taken away. Cut out. Hence, what does that mean? Subtract, right? So we're going to subtract that area. So that is what we want to do. So the large rectangle, the large rectangle will be 3 times 4, right? Which is 34. No, it's 12. It's 12 square meters. Okay, so that's 12 square meters right there. And then we have a triangle. So the triangle, I would assume that, I can't always assume, but that looks like a right angle right there. And the base of that triangle, I'm going to call that base right there 2. And I know that to be 2 because this is 1, and the whole length is 3. The length is 3. So now that triangle is going to have the same area as the other triangle. So let's just get that out of the way. So that triangle is going to have an area, basically you're just doing 2 times 2 divided by 2, which is 4 divided by 2, which is 2 square meters. 2 square meters. And this works, doesn't it? Can you see? You guys see how that works? 12 minus 2, right? We're going to subtract those. We're going to subtract those values. We're going to find the difference. And that leaves 10, right? You got 12 minus 2, which is 10 square meters. Personally, I think that's easier. Maybe you do too. If not, it's your opinion, and you're okay to have an opinion. All right, number 6. Elena and Jada both read at a constant rate, but Elena reads more slowly. For every 4 pages that Elena reads, for every 4 pages that Elena can read, Jada can read 5. All right, so what we're going to want to do on this one is harken back to a previous unit and figure out the constant proportionality. Now the constant proportionality, so this is like, this is like our x, this is our y. And our constant proportionality, remember, is a matter of just taking your y and dividing it by x. Taking your y and dividing by x, you can just do that. So right here, we have a y, we have an x, and we can just do that. We can just do 5 divided by 4. And that is 1 1/4, 1.25. 1.25. And the way that constants of proportionality work is that you can multiply by them, right? Multiply that by the x, and you'll get the y every time. So, and it's a constant, and that means we're going to multiply it every time. So you're going to multiply 1 times 1.25, and that is 1.25, right? You're going to do 9 times 1.25. All right, and that is going to be like 11.25. All right, this is where it gets a little algebraic right there. So when we do e times 1.25, you're going to get use the same color scheme, I always do that, 1.25 e, right? Or, 1.25 is also 1 1/4, which equals 5/4. So if you want to write it as a fraction, you can write 5/4 e. as well. That works. Now for this one, we're going to divide this one. Let's divide this by 1.25. Let's divide that. So 15 divided by 1 1/4 is 12. So that equals 12. Right there. And now that we're just given an expression there, so we're going to divide that by 1.25. But we just need to write an expression for this one. So this one's just going to be j over 1 1/4. Just like that. All right, here's an equation for the table. J equals 1.25e. What does 1.25 mean? What does that mean? That means that we're looking at the number of pages that Jada reads per page that Elena reads. Let me write that down. Slow down my thinking here. But that means that Jada reads 1.25 pages for every 1 page Elena reads. That's what that means. Okay? So she reads 1/4 of a more page every time that page reads 1 page. Elena reads 1 page. All right, write an equation for this relationship that starts with E. All right, so E equals, and it's kind of like what I wrote over there. E equals J, I don't want to do that. Oh yeah, I can just do that. J divided by 1.25.